So this all are symmetry. See, this one is symmetrical here. This one is symmetrical. In short, symmetry about xy. So xy is we are taking as axis. Xy, it is our axis. So it is symmetry about x, a, then e, b, y. That is our axis. Why? Because above this line, it is the mirror image of below. Upper part is mirror image of lower part. So therefore, VC will be equals to VE, which is equals to VD. So potential difference across C is equals to potential difference across E equals to potential difference across D. Right? As it is mirror part or mirror image of above and below or upper part and lower part. So VE and all this we are same. VE, VC and VD. So we can redraw this. This is our new image or resultant form. C, X, Y, A, B, and D. So which is equivalent to, if we solve this one, it will be in series. This two will be series, this two series, this two series. C plus C by 2, 1 by C plus 1 by C, C by 2. Okay. So we will get like this. C by 2, C by 2, C by 2. So finally, what are we getting? A, B is 1, 2, and 3. 3 C by 2. So what was our easy part? We have removed this 2, 1 and 2. We have removed this 2. Because there is no potential difference across, sorry, there are equal potential difference across C, E, and D. So we are removing E, so that there won't be any capacitor in between C and E and D. Understood? Pavan,
Yes, sir.
Sai Charan,
Yes, sir.
Adyasha.
Yes, sir.
Okay. Now third one, similar to symmetry, it is method 3. Wheatstone bridge. Okay, if I ask you to solve this one directly, how will you solve? Will it be in series? See, find capacitor across AB. So how will you solve? Come on, tell me. Give me your idea. What do you think? If I ask you to solve across AB, so how will you solve? Pawan?
Sir, we'll take left side and right side both as parallel. Sir.
Both as parallel? Okay, so let me just redraw this one. This diagram is like this, A and B. Now, how will you solve this 3 and this 3 or whatever way? Which one will be parallel? Let's name it as 1, 2, 3, 4, and 5. This 5. So now name it which will be parallel, Pawan?
Sir, 1 and 3, sir. 1 and 3 both will be parallel, sir. And 2 and 4.
1 and 3 will be parallel. But see, if I take 1 and 3, if I take parallel, then he is coming in between. For parallel connection, he is coming in between. We need to solve this one 5 plus 5 first. Then
Sir, if we assume that it is connected to this cell, sir, by potential method also we can calculate, sir.
by potential difference also we can calculate. Okay. Fine. Yeah. And Sai Charan, what is your idea? What do you think? How will you solve this?
I think we should neglect fifth capacitor.
Okay. Why?
According to Wheatstone bridge.
According to Wheatstone bridge, we need to remove. Okay. If we are not removing, then can we solve?
No, sir.
If we don't know what is Wheatstone bridge, can we solve this? There is no possibility. What about Adyasha? What do you think? Is there any possibility of solving?
Sir, I didn't get this one, sir.
No, I'm saying, like, can we solve this question?
Sir, it is possible to solve, I think, by removing the fifth capacitor, sir.
Yeah. If we remove fifth, it is easier. Directly, this will be series, and parallel. But if we don't remove, can we solve it?
No, sir.
Okay. Okay, actually we can solve it, but it is too complicated by delta and star method for resistance, right? Similar way we can try, but why to do that? We have Wheatstone bridge. So that is the need of Wheatstone bridge, so that it will be easier to solve. So in that, okay. So when C1n, let's name it as C1 here, then C2 here, C3 here, then let's take C4 here. Okay, C1 and C3 is equals to C2 and C4. If these ratios are equal, it is called balanced Wheatstone bridge. In that, no charge is accumulating in C5. In C5. So here we can simplify that C1 plus C2 and C2 plus C3. They both are in parallel. So if we solve directly, 1 by C equivalent equals to 1 by C1 plus C2. Across AB, right? Plus 1 by C2, C3 and C4. Okay, see, if you can't understand this one, let it be, don't worry. Just make it C2 and C1 parallel, sorry, series. Okay, and C3 and C4 series. And those two series are in parallel. Simple. Those two series are in parallel. So what did I say? C1 and C2 are in series. And C3 and C4 are in series. So this will give you, these are in parallel. No doubt, right? In this one, easy. Right? Is it easy or not?
Yes.
Disha, Pawan, Sai.
Yes, sir.
Yes, sir.
Okay. Sorry. Other form of Wheatstone bridge are so this is C1, C2 and C3 and C4, and this is C5. So we are centering C5 so that we can remember, okay, C5 is the center capacitor. So it is Wheatstone bridge again. So C5 will remove. So if I remove C5, then what will I get? What thing will be parallel and what will be series? Come on, tell me, Adesha. Which one will be series and which one will be parallel? If I remove C5 here, if I remove C5, so which R will be, which capacitor will be in parallel and series? Tell me, come on.
Sir, I think C1 and C4 will be in series and C3 and C2 will be in parallel.
Okay, let's check. Okay, any other answer? So it is like that. We are removing C5 means it will be like this. Did I make any difference here? Now, do you want to change your state answer, Adesha? Or
No, sir.
are you sure of C1 and C4 you said, right?
Sir,
Yes, sir.
Okay. Yes,
Sir.
Pawan.
sir, C1 and C3 will be parallel, sir, and C2 and C4 will be parallel, sir.
Okay, why so? Here there is
Sir,
a
I used
connection here.
potential method, sir.
No, but here there is a connect. This C and C4 is connected to C3 here. Will it make any difference? Is this connection is going to make any difference?
No, sir. Sir, I assumed before that point as X, sir, X as potential.
Okay. Yes, that is the easiest way you have to do. See, if you still get confused with this thing, so what you do, simple way, give a name. P, sorry, P, Q, R, S. So point out P, Q, R, S. P, Q, R, S. Now between P and R, okay, so R should be here, S here. Between P and R, there is one capacitor. Between P and Q, there is one capacitor. So this is not there. And R and S, one capacitor. And Q and S, this one capacitor. And P and S, A and B. It is A here, it is B here. So between P and Q, which number? C3. P and Q. P and R, C1. R and S, C2. S and Q, C4. See, now it's easier. Now you can say, now tell me, Adesha.
Yes, sir.
Right? This one we can join and this C1 and C3 here. So we can solve it.
Yes, sir.
But actually I used here two values, but here these two junctions are same. So I can draw like this, sorry, capacitor, this capacitor here. These two junctions are same. So these two parallel, then series. Now another, this is also Wheatstone bridge. This is also Wheatstone bridge. You tried expanding and check. Okay, you try expanding and check, is it coming Wheatstone bridge or not, and tell me. Now, last one is KVL and KCL, Kirchhoff's voltage law, and all that. Okay, that we'll study next chapter. But as I said, like before, we have studied a little bit what is KCL and KVL. Sorry, KVL, not KCL. Kirchhoff's voltage law. Summation of voltage is equals to 0. Okay. So let's start some numerical. Have you done this? Writing all that?
Yes, sir.
Writing part done, everyone? Done? Everyone?
Yes, sir.
Okay. This is voltage supply. 6 voltage, 4 microfarad, 5 microfarad, 2 microfarad, and 3 microfarad. It's very easy. Come on, solve it fast. Then we can do some good questions. Okay. Solve it. So let me ask first Adyasha. How will you start?
So first solving this 2 microfarad and 5 microfarads, sir.
Okay, then
And then that one solving it with 3 microfarads, right? Then solving it with 4 microfarad and then
okay, Pawan,
Sir.
for parallel, what's the formula? You remember?
Yes, sir. Parallel. Sir. C equivalent is equals to C1 plus C2, sir.
Very good. And in series?
Sir, in series 1 by C equivalent is equals to 1 by C1 plus 1 by C2.
Okay. So here question is find charge on 5 microfarad capacitor. Okay. Then science children, what we'll do here? They will ask across 5 microfarad. Sai,
Sir,
what we'll do here? They will ask across 5 microfarad. Any idea?
C equal to Q by V.
Okay. But we need across 5.
Q equal to CV.
Your formula is correct. I'm asking for 5 across 5. How we will reach across 5? Because if we find directly Q equals to CV, then we'll find total here. Total charge. We don't want total charge. We want across 5. Then what we'll do?
Don't know, sir.
Okay, go step by step. First get C equivalent. Now see, there is a voltage across this one same because it's in parallel. So here also 6. So let us remove this part. So let us assume that this capacitors is across 6 voltage. If we have charge on this capacitor, then we can find out. So how to find charge on this one? By this, because in series Q will be same. So Q equals to CV. So C will be 3 and it will be 6. 3 into 6, 18 microcoulomb. 18 microcoulomb is passing from here and it is dividing into 2 parts. But we cannot use 18 here because this V is common for both, total V. It is not possible here. But we can try this way. See, this voltage is common here. Right? If we find total capacitor, we can find total charge on it. Now, in total charge is dividing into these 2 charges. So we can find charge Q1 here and remaining Q2 is flowing from this one. Are you able to understand what I'm saying? Or shall I solve and show you? Guys, you want to give a try or shall I solve and show you?
Sir, is answer 9 microcoulomb, sir.
1 second, let me check. Yes, it is correct. 9 microcoulomb. What about you both, Adesha and Sai?
One solve, sir.
Okay,
So I'll solve it.
okay, try. If you don't get, I'll solve it here. Don't worry. positive and negative, both possibilities. Okay. Yes, Sai. Till where you reached? Did you find total equivalent capacitors? Adisha? C equivalent is
Sir, I got equivalent capacitor as 6.1, sir.
6.1. Okay. What's your answer, Pawan? 6.1 equivalent capacitors?
Sir, I also got 6.1, sir.
Okay, both of you got same. Okay, then it might be correct. Pawan, is it 6.1 your answer? Because I have your final answers.
Yes, sir.
Okay. Okay, then what you will do, Adisha? Then any idea how will you proceed? We got the C
Sir,
equivalent. Fine.
Q is equals to CV, sir.
Yeah, you will find Q there. So, but that Q will be for total. Okay. This Q you will find. Then what you will do? Okay, let's find. Let's do step by step. Find out that. Tell me each value, so I'll write here. So C equivalent is 6.5, right? Microfarad. Then Q equals to CV. 6 into 6.5 into 6. 6 6 are 36 and 30.
Sir, it is 6.1, sir, equivalent.
Oh, 6.1.
Sir, I got the answer.
Okay, so what is Q here?
Sir, total Q, sir, 36.6.
36.6 micro coulomb. So you got 9. Okay, somebody wrote something. No, this answer is 9 microcoulomb. Okay. So let me show you one shortcut to solve, or you can solve it anyway. It's not shortcut, but what I find easy always to do. Okay, so first what we did here, we have 6 voltage given, right? This is A and B. If I take across AB, 6 voltage, and 2 and 5 are parallel. So C will be 7. And C equivalent for A and B across this part. Okay, I'm talking about this one only. See, I don't need this one, 4 microfarad. So I'll just solve for this. C will be 3 and 7. So 1 by 3 plus 1 by 3. Sorry, 1 by 3 plus 1 by 7 into 3, 7. 21 by 7 plus 3, 10. Means which is equals to 2.1 microfarad. Okay, charge on that one, Q will be CV, which is 2.1 into 6, which is 12.6 microcoulomb. Or if I keep like this, 21 by 6, or 63 by 621 by 10. So into 5. So 123, 6, 5, 5. Either way. So potential across 3 voltage, sorry, 3 microfarad, potential across 3 microfarad is, let's take it as V1. V1 equals to Q by 3, which is, what is Q here? 63 by 5 into 1 by 3. Or we can say 3 in 21, 21 by 5. 21 by 5 voltage. So remaining voltage is that side. So V2 equals to 6 minus 21 by 5, which will give you 39, 9 by 5 voltage. So 9 by 5 voltage is across this one. Okay. So Q equals to 5 into V2, which is 9 voltage. Sorry, 9 microcoulomb. No need to get any other extra values. Actually, I was explaining and I was solving, so it took long, but this is the shortest method we can solve. Directly we can solve. Do you get it? Or you see, you did, if you have done in some other method, then write this one. If you're done in this method, it's very good. Not method or some way. Make a note of this one also, if you have not written. Okay, you just join. So let me show you question also. Once you complete writing, tell me. I'll go for next question. Done writing, guys?
Sir, done. Sir.
Okay. What about us? Sai Charan?
Done, sir.
Okay. Adisha?
Done, sir.
Okay. And Jafar? Okay. So you can solve in any method, but find your easy way. Because we need to save time. Each minute makes a difference in your competitive exam. That's what call it. That is what call it competitive exam, na? We need to save time because everyone know everything. So we need to be like, okay, how I can beat others by saving times in and solving or taking whatever questions you don't know, take time in that. So save time in somewhere and you can utilize that time. Insulator copper wire nahi. Okay. Okay, try this one. This is also easier, but it seems difficult. No, it is not. Okay. Don't start drawing. Wait. Now we can start. These all are capacitors. 20 voltage. 2 microfarad, 4 microfarad. This was a 4 microfarad. Sorry. 2 microfarad. 3/2 microfarad and 3/2 microfarad. Yeah, we have option also here. Okay, question is, here, find charge across C. Find charge across C. Microcoulomb, B 40 microfarad. Is it printing mistake? Okay, let it be. 10 microcoulomb. Okay, just for confusing, they are giving farad. See, that means these two options are ruled out. We have only 10 and 20. Find out, is it 10 or is it 20? Come on, guys. Do it. Don't take more than 2 minutes. Do any method, whatever way you find easy, do it. Find out charge across C. Series, so 1/4 plus 1/4, 2/4, 2 and 2, 4, 4, and this means 2. Okay, 4 and 2, 6. And 3/2 and 3/2, again parallel. And it will give you 3, 6 and 3 series. The 2 means 10. Okay. So I think it should be 10. Okay, you solve. I'll not solve. Yes? Any progress? See, 2 minutes over. Adyasha,
Yes, sir.
you got an answer?
Sir, doing sir.
Achha. 2 minutes over. Do it fast. Pawan.
Sir, solving.
And Sai.
Doing, sir.
Okay. Jafar.
So doing.
Okay. Don't be quick because already 2 minutes or more than 2 minutes. It's 3 minutes over.
Sir, could you explain this?
See, first, just go with this one. It's equivalent, you will find out, right? Now, this voltage is across here and here. Okay, if I find charge, one charge is flowing here and one charge is flowing from this one. Let's take Q1 and Q2. So that Q2 is again dividing here. Okay, so first of all, let's make it easier. Draw a diagram, easy diagram first. First, this is okay. See, we need across this one. So this thing we can solve it. We can make simpler. So if we draw one simple capacitor here, one capacitor here, one capacitor here, one capacitor here. We keep here, if we don't, and let's solve this one first. This will be like this, one capacitor here. Now, can you make it easier? Now, can you solve it? See, what is this capacitor?
Sir, once again explain, sir. I couldn't get it.
Okay. Eraser full. Now, I just made it a vertical, right? Can you understand this one? This makeover,
Yes,
you
sir.
understand? Right?
Yes, sir.
Okay. Now, we cannot solve this one. We cannot simplify this too. Because there we have to find out. But we can simplify this 4. So simplify version is here. Simplify this 4. How will you simplify? First series, then parallel, then again parallel. That is the answer. So tell me the values. 2 is parallel with 4 series 4. So first step is your series. So 1/4 plus 1/4, which is 2/4, which is 2. 2 plus 2, which is 4. So first, second done. So let me again draw. This is capacitor, not. Okay. This is 4 and what is nearby? It's 2. This is 3/2, 3/2. What is the battery? What's the voltage here? 20. So this is V1, this is V2. Okay, so can you, same thing you can follow up with the first previous question now. V1 and V2, find out V1, V2. It is same thing, right? See this part? Same thing, solve this one, means it will be, if I remove this, it will be 6. Now it is similar. Yes or no? Can you solve it now? Guys, can you solve it now? Are you able to understand? Sai Charan?
Yes.
Pawan?
Yes, sir. Sir, trying.
Sir, I'm getting 40, sir.
40. So, oh, second option.
Sir, 40 microcoulomb, sir, not microfarad.
But here we don't have 40 microfarad a coulomb. Let me solve it. Six, 5. Here we don't have option like this. We have 40 microfarad. So 3/2 plus 3/2, which is 3. Three microfarad, 3 microfarad and 6. So C equivalent will be 6 into 3/9. 18/9, which is 2 microfarad. Right. So Q equals to CV. It is 20 into 2. 40 microcoulomb. It is passing through this one. Okay. Now, so V1 equals to Q by 6. 40 by 6. Forty by 6, how much?
6.6 bar.
6, right? Voltage. Okay. So 20 minus 6.66 will give you 13.33. Or let's keep it like this. 20 minus 40 by 6. 6 and 80 by 6. Okay. This is V2.
Sir, 20 microcoulomb, sir.
It should be 20 because it's given option as A, but let us solve and prove it. Q equals to CV. C is how much? 3 by 2 into V is 80 by 6. 40 to 20. Yes, 20 microcoulomb. So option A. What is option A? Yes, this is correct. This is not correct. Check it. Have you cleared this doubt or any doubt in this one? Guys, tell me. Adisha, Jafar. Okay, Pawan.
No doubt, sir.
Okay. Shall I stop sharing? Okay.